Everyone. So we will continue with the applications of BJT. So in this circuit diagram, you can see how a transistor can be used as a switch to turn on and off the LED as a lamp. So you have a BJT here, and the LED is connected to the collector of the BJT through a resistance RC, and you can also see the base, and the emitter is connected to the ground. So you are giving the square wave is given as an input to the base. So when the square wave is at 0 volts, the transistor is at cutoff and there is no collector current. So the LED does not emit light. So it means it is off. When the square wave goes to high level, the transistor saturates. This forward biases the LED, and the resulting current through the LED causes it to emit light. So thus the LED turns on by blinking on and off. When V in is high, it turns on, and when V in is 0, it turns off. So this is 0 and this is high. And now we will see what is a feedback amplifier. A feedback amplifier is one which is used to amplify the input signal without changing any of its characteristics except the amplitude. So it literally means that you are giving the output back to the input as a feedback, so that one thing is you can amplify, and one more thing is for the correction factor, right? So this shows the diagram of a feedback factor. So this is the amplifier. The output from the amplifier, it has some gain that is fed back to the input through a mixer, and that goes back as the input to the amplifier, right? So the performance of amplifier can be improved by using feedback network which connects the output to the input of the amplifier. Now here they have considered the input signal as V in. It is applied to the mixer of a network which is combined with feedback signal Vf. The difference of these signals Vi is the input to the amplifier. So difference of these signals is the input, and a portion of amplifier output is connected to the input, as you can see in the diagram. So if feedback signal Vf is in phase with the input signal Vin, it is called positive feedback. If it is in phase, if the feedback signal Vf is out of phase with the input, it is called negative feedback. So you consider the block diagram of a negative feedback. So what is a negative feedback means? If it is out of phase, you get a negative feedback. So input is given to the amplifier, the output from the amplifier is fed back here, so which is negative. So that results in a negative feedback. So in this case, what happens? A is equal to V naught by Vi. What is A? A is the gain. V naught is output, Vi is the input. Output by input is always the gain of an amplifier. So this is a basic amplifier without feedback, and it is known as open loop gain. So if it is AF, so this is with feedback. Normal A is without feedback, AF is with feedback. So it is V naught by V in. This is the overall gain of the amplifier, and this AF is called as closed loop gain. And here Vf is the feedback signal, beta is the feedback factor. So here we have A is equal to V naught by Vi, AF is equal to V naught by Vn. If you equate this, you get V naught is equal to AVi for this particular equation, and you have Vi is equal to Vin minus Vf, which is equal to Vin minus beta V naught. So Vf is equal to beta V naught. Okay. So if you substitute in the above equation, you get V naught is equal to A into V in minus beta V naught. V naught into 1 plus A beta is equal to A V in. The overall gain with feedback, you get it as AF is equal to V naught by V in, which is equal to A by 1 plus beta A. So this is for the negative feedback. So it reduces the gain factor by 1 plus beta A. And this negative feedback is also called as degenerative feedback. So here are some properties of negative feedback. One thing is it gives reduction in gain, desensitize the gain, reduce non-linear distortion, reduce the effect of noise, control the input and output resistance, extend the bandwidth of an amplifier. And it also has some advantages. So advantages are it stabilizes the gain, higher input impedance, lower output impedance, increased bandwidth, reduction in noise, more linear operation. And there are some types of negative feedback. They are voltage series feedback, voltage shunt feedback, current shunt feedback, current series feedback. So among these, amplifiers employing voltage series feedback topology is discussed in the next video.